Alright guys, we're going to do example 3 now. Now at the end of the last example we got cut off by just a little bit, but the main point is this. We're going to be able to find critical points of functions by using the first derivative test and locating critical points on the inside of an interval by setting the derivative of the function equal to 0 and finding any place where the derivative might be undefined. We also need to look for critical points at the end points of the interval because it may end up that one of our critical points, like in this example, is actually somewhere at the end of the interval, and that's not going to show up on the first derivative test. Alright, so let's do an example. So this is example 3 out of your book. Find the absolute max and min values of f of x equals x to the 2/3 on the interval -2 to 3. We're going to do this analytically first, and then we'll look at a graph and verify our results. So the first thing we're going to do is we're going to take the derivative, and we're going to get 2/3 x to the -1/3. And then I'm going to rewrite this just so it's a little bit clearer what we're looking at. So there's our function. It doesn't appear as though there's any way that this function will ever be equal to 0. But we do have a place where it's undefined. If x is equal to 0, then f prime is undefined. So that's going to be our only critical point. So we're going to want to check the function, not the derivative, for its value at 0. We're also going to check the endpoints. So our only critical point is at x equals 0. We also need to check the endpoints. So we're going to check f of 0, that's our critical point, and we're going to check our two endpoints because they're inclusive, -2 and 3. And again, we're going to plug this into the original function. So the original function f of 0 is 0. F of -2 would be -2 squared root 3. And so that's going to be the cube root of 4. And then 3, that's going to be 3 squared and the cube root. So it looks like this is our largest value that we got, and this is the smallest value. So because, 0 is the smallest value. So because f of 0 is the smallest value, that means that x equals 0 is the location of a absolute min. The value of the absolute min is 0. And in the homework you're going to see that they ask you different questions. Where is there an absolute min? In that case we would say at x equals 0. Or they might say, what is the value of the absolute min? And in that case we would write, well, the function is equal to 0 in this case. So you want to read the question really carefully. We have an absolute max at x equals 3. And the value of the absolute max is the third root of 9. So again, we want to be really careful about what they asked. In this case, they just asked us to find the absolute maximum and minimum values. So they want the value, not the point. They're not asking where it is. They're asking the value of the max or the min. So that's what we're going to give them. -2, in this case, x equals -2, is a local max, but it's not an absolute max. And because they asked for in the question absolute, we're only going to list absolutes. So f equals -2 is a local max since it's an inclusive endpoint, but it's not an absolute. If we were to graph this function, we'd see this. Those are our endpoints. So we can see here's our min, x equals 0. Here's our absolute max, x equals 3. And here's our local max, x equals -2. And again, we didn't include that local maximum because they asked just for the absolutes. So our absolute minimum is right here, and our absolute maximum is right here.